Hi, everyone. Welcome to Unfiltered Flow ELSC, the podcast dedicated to the progression of the fluid power and automation industries. I'm Meghann Cook, and today it's my pleasure to welcome Casey Ruttan to the show. Welcome, Casey.
Thank you. Thank you. It's good to be here.
So, for our viewers, I've been following Casey on LinkedIn. He does all kinds of cool things with rebuilds, repairs, and schematics involved therein. So, Casey, why don't you tell us what you do?
Sure, sure. Well, I mainly run the business side of a repair shop in Jacksonville here. And what that really entails is I take care of all of the billing and all those business transaction type things. But I also, having a fluid power background, I field all the calls. I answer all the questions that are in the how much will this cost and how long will it take kind of thing. I had my own shop in the past, so I just apply those same experiences that I had before to this shop here, and it's great because the owner, who is an extremely good technician, has he rebuilds pumps, cylinders, you know, uh, basically all things fluid power, and he's seen a little bit of everything. But where he was looking for assistance was on the technical side of things, or on the computers, internet, looking up pump specs and things like this nowadays. And so we complement each other perfectly. And so I kind of run that side of the company for him, and then I'll handle any kind of consultative type calls as well. We get a lot of that. And he wasn't really offering that kind of work before, that kind of help before, and so I was able to offer that as well. Is a little bit of phone troubleshooting, kind of like a bit of analysis of symptoms of what they're saying, is going on with their system. There's a real lack of understanding of fluid power systems out there, so it's incumbent on us as the experts to ask the right questions and look for the answers, or look for them to reveal the symptoms to us so that we can help to better advise them, right? Like like if somebody calls you up and says, they're explaining that they're having trouble with a cylinder actuating or something like this. Well, we don't necessarily just say get the pump out of there, because it could be something else, right? It could be a sticky valve, it could be
Right.
a who knows. Um so that's worked out well. I get to do that, and while I've been doing that, I also started a hydraulicschematic.com, which is a service dedicated to producing schematics from whatever it is that you have. So if you have an old folded up, covered in oil piece of paper that is on the third shelf over from the fourth locker in the back of the storeroom behind all the used tires. You know what I mean? If you have a schematic like that, what I try to do is take that and bring it up to today and provide you back with a PDF, something that's printable, something that you can laminate, something you can blow up, things like that. And I started that in May this year, I think it is. And at the same time, I started to explore and post a lot more on LinkedIn, and it's been fun. I've taught fluid power in the past, and so it's fun for me to write articles and make things kind of instructional. Try to make it entertaining but clear. I find that there's a need for more instructional type and clear instructional type teaching in fluid power, and so I'm trying to fill what I think could be a need out there, and I'm having a blast.
Listen, like I said, I've been following you for a minute, and I love your posts. You lay it out in layman's terms. It's beautiful. Yeah, love it.
Thank you, thank you. Well, I really appreciate that.
How'd you get started in fluid power, Casey?
Well, I was working in information technology in a tech support type role, and then I moved into management, and I did that for about 6 years or so, and all of that work went overseas, and the only work that was left here in the same company, it was a tech support call center that I worked at, but again, in a technical role, those jobs disappeared, and it just became a regular call center. And so I lost interest and decided that it was time to work with my hands. I grew up with race cars and you know d- rebuilding engines and like doing stuff like that as it was, and had a knack for it and really enjoyed it, and decided that it was time to do that. So I did a 1 year program at the college where I grew up in Belleville, Ontario, Canada, Loyalist College of Applied Arts, and I just ran with it. I had a blast. Met some great classmates and some great people that I still am in touch with today, and ended up teaching there later on, and started right after that at a local shop that half of it sold components and the other half did on-site service and troubleshooting and repairs and things like this. So I was there for a total of about 6 years and spent time in both companies. Ended up owning half of the service side of it for a couple of years before I moved on, and just had a blast. Then I took a break from actually spinning wrenches and doing components to doing safety training, which was really fun. Hydraulic safety awareness training that really hadn't been done too much in this industry before. And a former competitor of mine launched the Hydraulic Safety Authority of Canada, and I was with him for about 2 years. We had a blast getting that company off the ground and getting the training and out there and gaining awareness in the market and in the industry of these concepts. So that's another thing that is somewhat overlooked in the fluid power industry is the safety side of things. Things like protecting hoses, making sure that loads can be, loads are held in situations where we might have a hose burst or something like this. The lack of regulation in North America is interesting. It's always kind of been something that puzzled me, and I'm not big on more government rules, but it's kind of cowboy right now in the fluid power industry, and it always has been. So we tend to build systems, by the lowest bidder, and they tend to be a little less safe, or a little, I guess, less. They could be more safe than they are, I suppose, without going too far down that rabbit hole.
Well, you've done some of that overseas too, right?
Well, yeah, I went to the Cayman Islands for a couple of weeks when I was teaching for Hydraulic Safety Authority of Canada, and uh, did an entire week of training, and then a week of consulting type stuff where we kind of went around their sites, and we looked at their equipment, we looked at their gear, and made some recommendations, a lot of recommendations actually, on ways to improve, replacing hoses, general maintenance kind of things that if you didn't really truly understand, what 3,000 psi of oil, you know, screaming through a 3/8 hose means, then you're not really going to think too much about it. But then when you do start to gain this awareness, it can light a lot of people up. So I really enjoyed that. I had a blast. The second week, that, like I say, I went around with the techs and some of the management who didn't love all of the recommendations that I made because it cost
They're
them,
not.
I
All
was
they
going to
see
be,
is dollar signs.
yeah, which I also understand. I understand the business side of these things, and we can't just inflate the cost of machines and things like this. We do need to protect our people. So I tend to err on the side of people. That's not always the case. Yeah.
Well, so in the time you've spent, what do you consider your most fun or important project that you've worked on?
Did a few fun ones. I guess the funnest one was back in Belleville, Ontario. Actually, the facility was in Trenton, Ontario. It was a production facility that they had a room full of poppers that made mini rice cakes. At the time, rice cakes were a thing, but mini rice cakes weren't really a thing. They had one other production facility that they also, and at this particular room in this facility was idle. They couldn't get these poppers to work right. They're all hydraulic, and they couldn't get them to work right. This other facility that had the same machines, I believe it was in Mexico, was doing okay, but still not doing great with these hydraulic popping machines. They let me go in there. There were like 40 or 50 of them. And so I got in there one time, and they were all idle, and I got looking at them, and I just kind of threw it at the maintenance manager. Why don't you let me play with these? And so he did. I went through each one of them. I used to rebuild the cylinders for them when they were trying to make they were trying to get it work, and then to get it to work, and then the cylinder business kind of dried up. But so anyway, I rebuilt the cylinders on a few of them. I calculated the force that they were exerting, and I looked at the temperatures that they were used, like they had a heating platen in them, and they would shoot the rice into this little pad, and then a top platen comes down, superheats it, cooks it in like I don't know 3 seconds or something like this, right? And then it lifts up, and another cylinder pushes a plate out, and it knocks the rice cakes off, and it goes down to a conveyor, and off it goes. And so anyway, I got them working. It was the coolest thing. And the next thing you know, mini rice cakes were like a thing.
We're all over the place.
And I mean, I don't know if I get to take credit for mini rice
For
cakes,
many rice.
right? But hey, I guess I had a hand in it, and
Yeah.
and that was a super fun
Yeah, that's cool.
mainly because I really needed to get into some math and some calculations and some timings and temperature considerations, all this kind of stuff. Replaced all the seals in it with fluorocarbon, Viton seals, all those things that we do that people that aren't in the fluid power industry don't really know about. So yeah, it was a blast. And I would say I did one other cool project that there was somewhere around like like '05, '06 maybe. There was a really bad ice storm in the Midwest. Like anyway, there were hundreds of thousands or millions of people without power in Missouri, and an engineering firm that I did some work for in a kind of a very quick fashion needed me to travel to this coal-fired electric generation facility and replace a counterbalance valve on their coal stacker reclaimer. It was an 85-ton coal stacker reclaimer. It was a bit of an interesting. It was incredibly interesting and scary because I guess I was trying to downplay it a bit, but it was really quite scary because the stacker, the boom had a bolster, a parking bolster for it, kind of shaped like the uprights for the football goal, and you'd bring the boom down into the bolster, and then clamp it somehow, lock it in position, and then you'd be able to do maintenance on the fluid power system. So the bolster had been hit and was damaged and didn't work. So the engineering firm came up with this idea that we could just load the boom with coal, load the belt with the coal, and it would hold itself down. So and I remember sitting with the engineer planning this job, and I was like, I gave him the side eye, right? Like, this, so this has got an 85-ton counterweight on it, and we're gonna load it full of coal, and then I'm gonna have them lower it to the bottom, and I'm gonna take this counterbalance valve out of that's on the blind side of the cylinder. This is a 3-foot, like 36-inch, or like it was a huge cylinder, 36-inch bore with a 24-inch rod with I don't even know. It was incredible. It was like a 15 or 20-foot stroke or something like this. It's a big cylinder.
Mhm.
It's not something that you play with every day. So anyway, I really didn't. I was young. I was trying to keep this customer happy, and I wanted to impress this guy.
Obviously,
And
before your safety days.
yes, yes, I was super keen on safety always. I always have been. Like my dad drove an 8 second um super comp dragster at 100 that did 160 miles an hour. And so, it wasn't dumb for like to wear a helmet, or you know what I mean? Like,
Right.
I was always big on safety growing up and played hockey, and so, wear a mask and a helmet and all that kind
Mhm.
of stuff. And so this this situation I was concerned about, but I put it aside again, for business and for a potential continued long term relationship with this client. So anyway, I went down there, and what should have taken 20 minutes ended up being, I was there for 18 and a half hours straight, and finally got it changed. When I cracked it, the boom went up. The boom raised, and I was laying on the cylinder. It went all the way to the top. I tightened it back up right away, but in cracking it, I broke the O-ring, and so we powered it back down, but it wouldn't stay. It just kept rising. As soon as they let go of as soon as they put the valve in center position, it wouldn't hold. So we ended up having to power it down onto the top of, as close as we could to the top of the loading bucket of the largest Caterpillar front end loader they had, which was the largest at the time, was the largest or second largest front end loader that Caterpillar made. We basically strapped it to that. It held it. Like, we put, I don't know, 100, 100 huge straps on it. It was big as straps.
Wow.
This was also a union operation, so it took 20 minutes to get in there to the pit where where all the coal was, and the stacker was, and I'd be there for 20 to 30 minutes, and break would come up, or the end of a shift, or this, or something would happen. And so that was also a very interesting job. We got it. I got it out. There was no pressure on it. I put the new counterbalance in. We had ingested some air, so there was some bounce in the cylinder. They had to cycle it a bunch of times over the next couple of days. After 18 hours, I went back to the hotel, slept for 3 or 4 hours or something like that. Got up, got back in the car, went back to the site, and stood in the operator's or wherever it was, watched it cycle 5 or 6 more times, and then just said, "You know what, guys, keep doing that. You don't need to be paying me, whatever it was." By then it was I think straight time and a half, because of the amount of time that had been there
In
already,
there.
or whatever. There's no need to keep paying that for me to watch you dissipate the air out of this thing. Anyway, they cycled it a bunch more times. It was fine. It worked out, but who knows, right? It could have been a lot worse. It could have been.
Yeah, that's wild.
Yeah, that's
Well,
that's
so
probably
this
the
is a
wildest one.
good lead into the next question.
Sure.
Smart technology and IoT.
Yeah.
What are you seeing now that's changed in the industry in that regard?
Well, I some of the most interesting things that I'm seeing is, before I got to Fluid Power, I said I was in IT, and I built some networks and stuff like that, and so I still understand computers and networking and protocols and that kind of stuff, but I forget most of what I ever learned about PLCs. But it all still is very interesting to me. And one of the cool things that I see are a lot of these sensors becoming more readily available. They're coming down in price, and there's some interesting opportunities happening with data there. And I think that we're going to see some interesting developments with sensors and data over the next short while. It's
Yeah.
it's really something that's either somebody's working on or needs to be.
Like how you worked your way into
Right, right. If there's anyone out there that wants to talk about this, I'd like to talk about it.
Casey. So with the time that you've spent in the industry, Casey, and the changes that have happened, And the changes that are going on now, obviously, there's a lot going on and will be in the next 5 to 10 years. What would you say to somebody that is in the industry, either just getting started in the industry or has been in the industry for a minute? What skills and what type of additional education should they look at to be ahead of the game in the next 5 to 10 years?
I think one of the areas that we are most deficient in at the moment is actually a basic understanding of pressure and flow. That I think is, although fundamental, are difficult concepts to grasp. The information is dry. The teachings are difficult and boring and rather uninteresting. And there's a few people out there that are working in this area right now, and that are just doing incredible work. And then there's services or educational content available that still is kind of dry and difficult. You have to be really interested to want to dive into it and break it down. And even then, I can only, I can only take it in chunks, getting the old textbooks out and like, yeah, okay, so what is that, right?
It's such a Fluid power is such a tough thing to sit at a desk and listen to somebody talk about it. PowerPoint presentations, that sort of thing. It's one of those things that you have to, in order to retain it, at least for me, you have to get your hands on it. You have to mess around with it. It's really hard to digest all the information
Agreed.
sitting in a
Yeah,
chair watching a presentation.
you really have to spark several of the senses, right, to educate a human being.
That's a good way to put it, actually.
We
Yes.
right, like, we call it adult learning techniques, but it's really the same for children too. You need to read something to some degree. You need to see it to some degree, touch it, smell it, and all those things.
Nothing better than the smell.
That's right. And then eventually, we can really get to a mastery level of a concept when we teach it. That's that's really the last way, or the final step in, to me, in the learning process, is to then teach it. So that's just what I try to do, right? Like, with my customers and with my any of my colleagues. Like, I get emails and messages on LinkedIn a lot too. I get the odd request for a post, or for can you do an article on this particular concept or whatever. Um,
Which is awesome, though, right?
I,
When
I,
you
I,
posted that, was
it's,
that the beginning
it's,
of this week or last week? You said you had a request. Was that
yeah, it was
the
this year last week
pressure
for a,
sense? What was it?
it was a regen circuit. Yeah, and a fellow that's about to do do one of the certification exams, and was asking me about regen circuits, and I was like, oh yeah, regen circuits, they're kind of sneaky, and I got the book out too, like, it's not like, oh yeah, I just read, but regen circuits are sneaky. And so I got the book out, and I was like, oh yeah, yeah, I remember you, you little sneaky little bugger, trying to create energy where there isn't any. Anyway, I did a fun post about that, and it's just something I really enjoy doing, totally enjoy doing. And I would say, just to, spin back to that, to your question about what to focus on, for someone, again, I would say that there's a deep need for an understanding of, again, pressure and flow, those, the Bernoulli principle, Pascal law, those basic principles, but then applying those super basic principles to the area of a circuit that you're dealing with. Like, if you're going to work in the distribution game, which is tough, right? There's a lot of distributors out there selling a lot of great product, and part of the issue is folks don't know their stuff, but they also always we're not always applying those basic principles, because there's a lack of understanding. So if we have a customer telling us, this is wrong with the system, and we just order them a widget, and it doesn't fix the issue, or it does, but it's only temporary because we didn't really find out what was behind that. We didn't understand, and we didn't use those principles to investigate. Then we're really not doing service for anyone, including ourselves, right? So I think that if I was to give anyone advice at the moment, get to a level of understanding with pressure and flow that is that is clear and deep, and then break down what it is you're hearing, and solve it in a simple way. So troubleshooting, effective troubleshooting techniques, for instance, that's something I've.
Ask a lot of questions.
Yeah, ask questions, try to, it's you sort of, playing doctor with a fluid circulation system, right? There's similarities to the way that the body works, the way that blood flows and all this, those principles of energy and flow and pressure are the same anywhere you put them.
Yeah. What do you think the biggest challenge is right now in the fluid power industry, Casey?
Well, it's in a really interesting flux. We're about to have a serious vacuum, right? As we all know, over the next 5 to 10 years, we're going to see a lot of retirement. We're going to see a big drain on the knowledge base, and part of the issue is that locked in that knowledge base are all the settings for the test bench, and all of the crossovers of this valve to that valve, or this filter to that filter. What does the S mean in the part number of a cylinder? All of that knowledge is hidden in the bank of knowledge that is about to retire over the next 5 to 10 years. And so we need some CEOs and some folks that run these companies to just start planning a little better about succession, and let's get that all this stuff documented so that we can curate it and efficiently pass it on to the next generation, because we've got to get ready to build the next revolution of machines, whatever it's going to be, right? We have in all this doing all these things, and there's threats of humans losing jobs and all this kind of stuff, and there's a lot of things going on. You can't ever replace the human's creativity and human ingenuity, so we need to preserve this knowledge so that we don't devolve, right? We need to continue to evolve. So in let's get this stuff down. Let's get some databases built. Let's get some let's get this knowledge backed up so that we can tap on it.
Yeah. Very good. You're 100% right there, Casey, for sure.
Well, I just want an opportunity to do it, and have a chance to help. So that's my bigger picture, is to see if I can up.
And you are. Like I said, I'm so glad you joined today because I love your posts and I love what you're doing. It's awesome.
Well, thank you. It's a pleasure to chat with you, and I'm available anytime.
Thanks, Casey. I appreciate you.